Hi everyone, today's lesson is for Algebra 2 honors students covering Chapter 4, Lessons 4.8 and 4.9 for higher order systems, determinants, systems with graphing calculator, as well as solving inverse matrices. So let's get started. Starting off with just methods that we already know for solving 2x2s. One method we started with is graphing method. And again, graphing method for a 2x2, really one of the most unreliable methods, because unless it's hitting right at the corner, you run the risk of it not actually, you not being able to see the answer. You have to solve it another way anyways. Number two, substitution, also elimination. We used CRAMER'S rule, and I also taught you augmented matrices, and I think some of you guys actually like that, but not sure. Today we are going to talk about inverse matrices, using inverse matrices to solve a 2x2. Okay, and for a 3x3, so far we did use a graphing method. In using the graphing method, we used what we call traces. And in using traces, those are, remember, a trace is like a portion or a fraction, a part of a plane. And if you have three traces and they intersect in one place, in one point, three planes are going to intersect in one point. You could, from geometry you learned that two planes intersect in a line, but three planes are going to intersect in a point. Of course, that's one option. You could have more options for that, but for this case of what we're doing is finding a solution to a system, we're looking for the point of intersection. So we graphed it using a trace, but we also graphed this, just keep in mind, you could also use, besides using a trace, you could also use the lines, meaning because a trace is going to use intercepts, and when you're using the intercepts, you're setting the other two values, the variables, equal to 0. So if I want to find the x-intercept, I've set y and z equal to 0. However, I could use the intercepts, like set x equal to 0, but that's going to leave me y and z, and that's going to give me a line. And so what that does is it actually gives me three lines. So for example, if I had the three lines by setting, the intercepts equal to 0, you got the xy intercept, you've got the zx intercept, and the xy intercept. That might give you three different lines. And in which case, instead of graphing by intercepts, you're actually graphing by those three xy line, those three intercept lines, and then the result is whatever's in the middle is that trace. And so that's another option. And you have to do that for each problem. So for each equation, so that's like a lot of work. We also did, for 3x3s, we did back substitution. And if it didn't set equal to like x, y, or z, where you could back substitute that value in, then you actually had to use elimination to solve the 3x3. We talked about, last lesson we did CRAMER'S rule. And with CRAMER'S rule, remember, we did the shortcut method actually. Today I'm going to show you a little bit different method. And today, what is called higher order determinants. And we're using CRAMER'S rule setup, but we're using the higher order determinants to solve. And lastly, calculator method. And so we're going to explore all these options for today. So let's see how far we get. All right. So today's actual targeted learning for objective for today is solving a system with three or more linear equations using the higher order determinants. We are going to use inverse matrices to solve a 2x2, and also use a calculator just to show you how to use that, because why not use it if you're short on time, especially if you're taking an SAT or something like that. where you just have a specific amount of time and they don't really care how you solve the 3 by 3, even though you're like, I know all of these different ways to solve a 3 by 3, but they only want to know the quickest way and the answer. So we're going to start off with a warm-up and solving a 3 by 3. We're going to solve this by elimination. Of looking at this and my x, y, z's, I'm actually going to eliminate my z's. And so let's see, I'm going to combine the first two equations. Now remember, whatever two equations that you're actually, solving for, you need to make sure that you are eliminate the same variable twice. You have to do that twice. Otherwise, if you eliminate the z's in the first two equation and then you decide, oh wait, it'll be easy to eliminate the x in the next one, you're not really getting anywhere, and you'll realize that pretty quick once you start solving. So in order to combine the first two, what I'm going to do for this equation on top is I'm going to multiply that by 3 because my goal is to eliminate the z's. So what I have is let me multiply. Let me just do it at the same time. So 3 times 2, we have 6x plus 3 times 3. So that'll be plus 9y. Oops. There we go. 9y. And then 3 times negative z is negative 3z, and then equals negative 3. So we have 6, we have 9, and we have negative 3. Okay. And then for the second equation, I actually don't have to do anything to that because it already has a 3z. So we have negative x plus 5y plus 3z is equal to negative 10. I'm going to add these two equations together. 3z's are going to cancel, and we get 0z. Yes, you can put that in there, but that's not required. 6 minus 1, we have 5x plus 14y equals negative 13. So there's my x plus y. All right, so now I'm going to go back to my 3 by 3, and I'm going to combine two other equations, but my goal is to eliminate the z's again. So I'm going to choose to just combine the second two. And in doing that, I notice this is already negative 6, and that's a 3. So if I multiply the middle equation by 2, that should eliminate my z. So let me write this over here. We've got negative 2x plus 10y plus 6z is equal to negative 20. And then we have 3x minus y minus 6z equals 5. And because those are already 6's and they're going to cancel, I don't have to do anything to the bottom equation other than add. So now I've got negative 2 plus 3, which is x. We've got plus 9y. And then negative 20 add 15 is going to give us equal to negative 15. So now I've got these two equations. I'm going to combine those on the side. So I'm going to get 5x plus 14y equals negative 13. And I noticed, though, that if I were to multiply this by negative 5 while I'm moving it over, that's lessens one step. So that's going to give me negative 5x plus negative 45. So negative 45y is equal to negative 5 times negative 15, positive 75. I'm going to add those two equations up. These are going to cancel. X's are going to cancel. And what do I have? I'm going to use my calculator. Is negative 45 plus what? 14. How many is that? 31. So negative 31y is equal to 75 minus 13 is 62 positive. So dividing by negative 31 is going to give me y equals negative 2. So what I know so far is that when I'm looking for my solving the system and my intersection point for the three planes, y is equal to negative 2. So I already have that value. Now, in order to find the next value, I'm going to take what y equals and I'm going to plug it into another equation. So because that's just there, I'm going to use that equation. So I've got x plus 9 times y is negative 2, equals negative 15. So x minus 18, so minus 18, which means I'm going to add 18 to both sides. And I'm going to get x is equal to 3. So now I've got x is equal to 3. Now to find my last value, which is z, I'm going to plug it into another equation. So pick one, and it honestly doesn't matter which one you pick. So I'm going to choose the top equation. So we've got 2x, so 2 times x, which is 3, plus 3 times y, which is negative 2, minus z equals negative 1. So 6 minus 6, oh, those are gone. So I just have negative z equals negative 1, so z equals 1. So that means that my intersection point is 3, negative 2, 1. So that's it, and then I'm done. But of course, definitely you should check your answer. Don't plug it in the same one that you just solved to find z, right? The same one you used to find z. Use a different one. So I'll use the top equation. It says 2 times x. So 2 times 3 plus 3 times negative 2, subtract z. Oh, I just used that. I just said not to use that. Okay, sorry about that. Let me use a different equation. Just realized it. Hello. Okay, let's use the bottom, which says 3x. So 3 times 3 minus y. So minus negative 2 makes plus 2. Minus z. 6 times z. Z is 1. What does that equal? So 9 plus 2, what is that, 11? 11 minus 6 is 5. And 5 is my answer. Check. So we got that. The last thing that I would just suggest that you do is just to make sure that you can graph a trace, or actually graph the intersection point, because we have the intersection point here. So let's do that on our graph. So we know in the x direction, remember this is x positive, we're going to go out 3, out this way. And then, so like 1, 2, 3. And then in the y direction, negative 2, that's this way, 1, 2. And in the z direction, I'm going to go up 1. So actually, that point right there is my intersection point for 3, negative 2, 1. That's the intersection point. And what I talked about in class is drawing this ray that goes right to that point. Now, I do expect you to be able to draw that, as well as the graphing 3 traces separately, different problem. I also would like you to put the prism on here as well. So use your little drawing skills. Remember, all these prisms have a value that goes up like that. They all have this thing in the front. Connect the sides. What did I miss? Oh, that's got to be connected too. All right, and then that's it. And remember, the prism is that value that goes from 0, 0 to that intersection point. And that's ultimately what you're doing when you're solving a 3 by 3. So, oh, and I just did that. Okay. Next question. So the next one says a 3 by 3, use the 3 by 3, and we're going to use CRAMER'S rule, but I'm not doing the whole problem. I'm actually going to ask you something like this similar on the quiz or test, and I'm going to ask you to solve for one of the variables. So in this problem, I'm asking you to solve for y. So we're going to solve for y, and in doing that, we just have to isolate the values that we're using to solve for y. And so I am going to use, we'll use the box. We know all x, y, and z has to be on the same side. The x term does not have to be positive. 2, negative 1, 3. Then we have 3, 5, negative 1. Z is negative 1, 3, negative 6. So if I'm solving for y, remember that negative 1, negative 10, 5. We go in the x direction, or in the x column if I'm solving for x, y column if I'm solving for y, and z column if I'm solving for z. But because I'm solving for y, it's going to go negative 1, negative 10, and then 5. And then the two values on the right are popping up. So that's going to be 2, negative 1, and 3. And on the right, that's going to be negative 1, 3, and negative 6. Now remember, when solving by CRAMER'S rule, this shortcut method, we are going to rewrite the first two columns. So this is going to be 2, negative 1, 3, negative 1, negative 10, 5. And on the denominator, same thing. I'm going to just use a different color. We've got 2, negative 1, 3, middle column 3, 5, and negative 1. All right, so we are going to start multiplying. We're going to start in the top left corner, always start in the top left, and we're going to multiply out. So we've got 2 times negative 10 times negative 6. So that's what, 20 times 6, that's going to be positive, and that's 20 times 6 is 120. Okay, plus negative 1 times 3 times 3, so that's negative 9, plus negative 1 times 5, which is 5. We're going to subtract going back the other way. We're going to have 3 times negative, so that's 30, plus 5 times 3 times 2, 30 again, plus negative 6 times negative 1 times negative 1. That looks like negative 6. All right, so I am going to use my calculator. I'm going to go... I'm going to use, let's see here, 120. Use your calculator at the same time so you guys can check your answers. Plus 5, I get 116 minus this stuff. So that's what? 60 minus 6 is 54. So 116 minus 54, and I get 62 on top. Yeah. All right, so on the denominator, same thing. We're going to go 2 times 5 times negative 6. So that's going to be negative 60, plus 3 times 3 times 3. 9 times 3 is 27, plus 1, that's a negative 1. Subtract, go back up the other way. We have 3 times 5 times negative 1, so that's negative 15, plus negative 1 times 3 times 2, which is negative 6, plus 6 times 1 times 3 is 18, and that's positive. So, again, I'm using my calculator. 60 plus 27 minus 1 equals, I get negative 34. Over here, I'm going to get minus, and then this stuff in here is negative 15 minus 6 plus 18, and I get negative 3. This looks like this is negative 3. So negative 34 minus negative 3 makes plus 3, right? So negative 34 add 3, that's just going to be negative 31, which means that y is equal to negative 2. And going back to the other page, whoops, here's my y, negative 2. So I know that's right. We've already done this problem, right? So we know that we at least have y right. And so that's that value right here, which is y. Done. So I could do that for x and z if I wanted to. But what I want to show you now is how to use matrices, Cramer's rule specifically, using higher order determinants. So we're going to use the same problem. We already know the answer, so I like that. We're going to plug these points in just like Cramer's rule, but this is Cramer's rule, not shortcut, something different. So let's do this. So we're going to go 2, negative 1, 3, 3, 5, negative 1, negative 1, 3, negative 6. Again, if I'm solving for x, these go in the x value. So negative 1, negative 10, and 5. And then the two columns come up. And so that's going to be 3, 5, negative 1. And it's going to be negative 1, 3, and negative 6. Now, the rule for using higher order determinants is that you need to use something called an array. All right? An array is a sort of like a rule book, okay? But it's a rule book for matrices in that when you're looking at this, meaning I'm changing from I'm changing these matrices to determinants. And in doing that, what's happening is I'm actually changing the values of my coefficients, okay, based on their location. Okay, so this is the same. That stays the same, opposite, same, opposite, same, opposite, same, opposite, same. So I'm going to use this array in order to expand my one of my rows or columns. And you can pick any row or any column, and it doesn't matter. Just do one. Pick one row or one column. And so what's happening is I'm just going to choose the top row just for fun, just to make sure we can do this. And in doing that, that means I'm also going to expand the top row of my equation, which means that what I'm actually looking for is it's going to be negative 1. Okay, I'm writing that down. times some second order determinant. And then my next value, see that's positive 3, so I'm going to go plus 3 times another second order determinant. And then my last value is negative 1. So negative 1 times another second order determinant. Now, where I get those second order determinants have to do with, say, crossing something out. So like if I'm looking for the negative 1, right, value, I'm going to actually cross negative 1 out. So in doing that, that's what I get. I'm like, if I were to cross negative 1 out, like put an X right on the negative 1, that's what I would have left. Now, I want you to notice that what I would have left is those values in this little box here, 5, 3, negative 1, negative 6. So those values in that little box, right here, go here. So 5, 3, negative 1, negative 6. And then now I'm looking at the positive 3, right? So now I'm going to shift my array. I'm going to shift this over, my crossing out on the 3. And what's left is this value here. So that's going to be negative 10. Oops, let me put that there. So that'll be negative 10 and then 5 down below. You see these two right here? And then on the right, I see 3 and then negative 6. And then the last one is negative 1. So like if I cross out the negative 1, like that. Now keep in mind that when I say cross out, like I'm going to cross this out just because it's the last value and we don't really care. If we were to cross that out, and for you, I would suggest that you use a pen to draw this, like to write out the numbers. And then as you are crossing out the values, use a pencil. So every time you cross out a different value, you can just erase it, right? Okay, so negative 1 is crossed out. That was that value here. What's left is in this box, right? That's what's left. So we have negative 10, 5, and then 5, negative 1. Now, don't forget your array, because what this is going to do now is it's going to determine whether or not my signs for expanding the first column are going to stay the same or change. So for the first term, see how it's a plus? That means that's going to stay the same. That's what that means. Plus means the same. The minus value for this means it's going to change to the opposite sign. So how this was a positive 3, we're actually now going to change that to be negative. And then lastly, so this would be change, right? And lastly, the plus for the last value that I'm expanding is going to leave it the same. The plus sign means leave it the same. So all I have to do now is to solve those, or to simplify those 3 determinants, and we're done with the top of the numerator of the x coordinate. Okay, here we go. So this is, remember how to solve or to simplify a determinant. We go 5 times negative 6, which is negative 30, minus negative 1 times 3. Negative 1 times 3 is negative 3. Now remember, this negative 1 is scalar. That goes out front. It's just number times another number. Minus 3 times, and then again, multiply. That's what, 60 minus 15. Minus 1 times, and again, 10 minus 25. So here we go. Negative 30 minus negative 3 is plus 3. So that's negative 27. Yeah. Times negative 1 is 27. And then this is what? 60 plus, oh wait, hold on a second. This is 60 minus 15. That's, I didn't write that very well, did I? So 60 minus 15 is 45. And then 45 times negative 3. So I'm just going to, you guys know this in your head here. 35 minus 135, and then minus this stuff. So negative 10 minus 25 is negative 15. And then negative 15 is plus 15. So let's see what we get. I get 27 minus 135, add 15. Negative 93 is my numerator for my x. Okay, right on. So we've got that value so far. Now let's find the y, or the denominator. Just keep in mind that this will go a lot faster once you get better at this, as well as note that the denominators are all the same. So we don't have to do that again. So for this denominator, I'm going to, again, expand the top row just for this one, and the other ones I'm not going to. Okay, so we're going to go, I'm going to expand that top row, right? So that'll be 2 times a determinant plus 3 times a determinant minus 1 times a determinant. Now keep in mind, I'm going to put the array in right now. The top row again is same, opposite, same. Same, 2 stays positive, opposite, same. So this positive 3 is now going to be a negative 3, so I'm going to get rid of this minus. Now, again, what I'm going to do is I'm going to take my crossing out, and I'm going to cross out on the 2. And so what's left is this bottom corner here, which is 5, 3, negative 1, and negative 6. Now, if I'm crossing out the 3, oops, let me get rid of that. If I'm crossing out the 3, now I have negative 1, 3, 3, negative 6. And then lastly, if I'm crossing out the negative 1, what I'm left with, and I cross out the negative 1 like that, right? I have negative 1, 5, and then 3, negative 1. So when I solve this, right, and I find that bottom denominator, I got to multiply everything out, right? So this is going to be 2 times, and then negative 30 minus negative 3, so that's plus 3, minus 3 times, what's that, 6, minus 9, minus 1 times, that's 1, minus 15. Okay, so we've got negative 30 plus 3 is negative 27 times 2, right? You know that. 27 times 2 is 54, but that's negative. And then 6 minus 9 is negative 3 times negative 3 is positive 9. 1 minus 15 is negative 14 times negative 1 is plus 14. So I have negative 54. I have negative 54 plus 9 plus 14. So that's plus 23. And I get, looks like a negative 31. So if I divide 93 by 31, that's 3. So that means my x-coordinate is 3. So let me go back to what we did before. And, oh, there it is, right there. X is 3. Right on, we got it. That's always a good thing, right? Okay, so now let's just look for y and z, except for I don't have the values up here. Let's go back. Okay, so in going back, I just need to, oh, I know what I can do, is I can copy that here and bring it over here. There we go. I got it. Okay, so what we have here is, this is my equation, just in case I forgot. And so if I'm solving for y, this value, the negative 1, that goes here. So that's going to be negative 1, negative 10, and 5. And then these numbers go up. So negative 1, 3, negative 6, 2, negative 1, and 3. Now, I don't have to do this denominator again, right? Because what's my denominator? Negative 31. So we know that this bottom part is negative 31 for both problems, right? So I don't have to do that. But what I want to show you is expanding a different row or column, okay? So what I want to do is, let's expand the second row. Let's just do that. Let's expand, let's choose the second row to expand. So using my array, remember, that's going to be same, opposite, right? A 3 by 3. Same, opposite, plus, opposite, same, opposite, plus, opposite, same. And so what we have here is this new matrice. All right. And so when I'm working this out, I'm going to go, let's see, negative 1 times something. And then I'm going to go, and I'm going to run out of room. So let me move this out of the way for just 1 second. And so I'm going to have negative 1 times a value minus 10 times another value, determinant, right? Plus 3 times another value. And looking at this row in the middle, right? Remember that I'm expanding that. That's going to change my sign. So the first one is going to be the opposite, so that's positive. Same sign, and then opposite. So if that's a plus 3, now that's going to be a negative 3. Okay, so that's going to be negative 3. So now if I'm crossing out the middle row and column. Okay, so what I'm going to do, let's just use a different color. Crossing out the 1 here like that, that's gone. Okay, so that means that what's left is this value on top. So negative 1, I gotta get rid of that. Change my pen. Okay, all right, so here we go. Negative 1, and then 5 and negative 6. Right? That's it. Good. Now, moving this over, crossing out at the negative 10, I'm left with 2 in the top left corner, negative 1, bottom left corner 3, bottom right corner negative 6. And then lastly, I have that one that I'm crossing out. And I always, like I said, cross out, just write it on it. So I get 2, negative 1, and then 3, and then 5. And I already changed my array, so check, did that. So now I just have to multiply these out. So I'm going to go 1 times that, which is just 1 times that. 6 minus negative 5, which is plus 5, so that's 11, minus, what's that, 10 times negative 12 minus negative 3, so that's plus 3, minus 3 times, and that's 10 minus negative 3, which makes plus 3. So we have 11, okay, negative 12 plus 3 is negative 9, times negative 10 is plus 90, and then 10 plus 3 is 13, right? Yeah, 13, and I'm going to multiply, well, oh, that's just 39, and so 13 times 3 is 39, but this is a negative. So let's see what we get. So I got 11 plus 90 minus 39, 62. So that means that this top part is 62, and I forgot what the bottom, oh, it's negative 31, which means that y equals negative 2. And so if I check back on my answer from before, right, y, and I already did this before, y is negative 2. So you like this or you don't like this, I don't know, but this is sort of like a fun way to do this. I think it's called, again, higher order determinants. And the reason is that you've got a big determinant, okay, and then you've got smaller determinants. We call those second order determinants, okay? Now, again, so this is another way to solve a 3 by 3. I actually showed the solutions on here for one of them, and so you can just kind of, that works it out a little bit nicer, I think. So where we're going with this is that I really want to show you how to use a calculator to solve the either a 2 by 2 or a 3 by 3. So based on that, you actually need to know the why behind why the calculator works. And maybe you don't care about the why, but I think it's important to know that. And so these are what we come from, the inverse matrices. So a matrix, which is multiplied by the original matrix to get the identity of the solution. So that's what we're working towards. But basically, if you think about an inverse, right, like it's to the negative 1 power, what we're really looking at is like a reciprocal value, all right? We really don't write 1 over a. It's like if you divide by 3, you don't write, I mean, you could write 1 over 3, or you could write 3 to the negative 1 power, okay? And so it's very similar to something like that. So there's a formula, all right? Finding the inverse, which is here. It's going to be 1 over the determinant. Now, a lot of times when we write the determinant, when I say the determinant, that's what you're looking at, right? That value times the transpose. Now, the transpose is a little bit tricky because what the transpose does is it sort of transfers some of the numbers, but not all. For example, see this A and the D down in the corner? See how they're flipped? They changed. They did that, okay? Likewise, but not completely the same, okay, the B value is now a minus. It's the opposite. And the C value also the opposite. So basically what you're doing is you're finding an inverse. So we're going to start baby steps towards using our calculator, okay? But this is what an inverse is. So we're going to practice using an inverse. I will, heads up, full disclosure, these never come out perfect. Okay, so you're not, if you're looking for a no non-decimal, no fraction, that's not going to happen. Okay, just note that. Okay, so we want to find the inverse of this. So when I'm looking for the inverse, what I'm really looking for is this value saying 4726, and I'm looking for that. So I'm going towards that value to find the inverse. Now, the inverse is equal to 1 over the determinant, okay? So the determinant is this value in the original value. So that's going to be 4726. Now, that being said, what we do next is we have to multiply by the transpose, okay? So the transpose is now everything changing. So now my A value, which is 4 and 6, those are going to change. That'll be 6 and that'll be 4. Likewise, now this 7 will be a negative 7. This 2 will now be a negative 2. And so realistically now, all I have is 1 of the over the determinant. Now, I need to fix this. And that's going to be 24, 4 times 6, minus 14. So 24 minus 14 is 10. So realistically, this is saying 1 over 10 times this. 6, negative 2, negative 7, and 4. And like I said, unfortunately, there's no like super neat way of doing this. It's just, I'm going to move this over because I'm running out of room. So let's see if I could actually move everything over here. Move that way. Yep, there we go. And so what's going to happen is this 1/10, which is scalar, which means it's just a number, is actually going to be like multiplied into this. So you would have 6 over 10, right? So you're going to have 6 over 10, which you can reduce as a fraction, or you can make it 0.6. 2 into both, what's that? 2 into that is 3 over 5. 7, that's going to be negative 7/10. The bottom, that'll be negative 1/5. And the right bottom divided by 2 is going to be 2/5. And so that's my answer. That's the inverse. Now that's, like I said, it's not, we haven't solved anything, so we're not using the calculator yet, but baby steps. We're looking to first find what an inverse is. And what is down here is basically what we just did, but with fractions and decimals. And then lastly, you know, this chapter I've really been harping on checking your answers. By checking your work, what that means is if I were to, you know, like if you were to divide it out, when you multiply, you divide, right? So if I was going to check my work, I would take the original determinant, right, 4726, and I would multiply it by my answer, which is this, right? And you know, that's a 2 by 2 times a 2 by 2. And as you multiply and go this way, right, what that's doing is that's going to give you the identity matrix, which is 1001. And you've done this before. We did this problem before where we took like this and we multiplied by the identity matrix and we ended up getting the same value, 4276, right? You get the same value if you just multiply by the identity. But if you multiply the original determinant by its inverse, you should get the identity. And that should make sense. Because if my value is 5 and I multiplied it by its inverse, 1 over 5, I'm going to get the identity matrix for multiplication, which is 1. So the identity matrix or the identity for a matrix is 1001. So when I multiply those, I should get the same value. So think about that. Okay, so let's just do this one more time. Find the inverse. So again, in order to find the inverse of that, I'm going to go 1 over the determinant. Just rewrite 2, 3, 4, 5. And that's times its transpose, which is now going to be 5, 2. And then negative 3 and negative 4. So this right here is 10 minus 12, which is negative 2. So 1 over negative 2. So that's negative 1/2 times my matrix, which is 5, negative 4, negative 3, 2. The transpose, right? That's the matrix transpose. And then you just distribute that negative 1/2 in to get your final answer. And that's going to be negative 5/2, 3/2. Negative 1/2 times 2 is going to be negative 1. And this would be 2. And again, this right here is just what I just drew. Exactly the same. And then again, checking your answer, you take your determinant and you multiply by its inverse, and you should get the identity matrix, which is 1, 0, 0, 1. What this is like, why would we use inverses? Like, what do they have to do with anything? But basically, because we don't divide with matrices, right, we can multiply by an inverse, so that does achieve the same thing. But one of the main reasons why you want to use an inverse matrix is to solve a system of equations. So let's do that, and let's try this one problem first. And to set this up, there's like this little formula here on the side, but you're pretty familiar with this. I know you know that this is like that box area. So 5, 2, 1, 1. And if you're asking or thinking, can we do this with a 3 by 3? Absolutely, but not today. I'm trying to solve for x, y, so those values do go here. And again, my values at the end are going to be 11 and 4. So my objective for this problem here is to solve for x and y, which means that I need to see this 5, 2, 1, 1. I need to get rid of that. I need to move it to the other side. And because when I move something to the other side, remember, you're taking the inverse. Like, for example, if I had 2x equals 10, in order to move this 2 to the other side, right, I am going to take the inverse or multiply by 1/2, but that's the same thing as saying 10 times 2 to the negative 1 power, right? So that's the concept. That's what I'm actually going to be doing, is I'm doing the opposite function. So instead of multiplying, I'm dividing, but I'm dividing by the reciprocal. So when I bring that up, okay, that's the inverse. So what we have is this. XY, because remember, XY is now isolated. We're trying to solve for X and Y. Remember, we're trying to find the intersection point. So when this moves over, what then happens is I've got 5, 2, 1, 1. I'm looking for that value as an inverse, but I still have to multiply by 11, 4. Okay, when I'm done. Okay, so let's do this. This is going to be fun. We are solving for X, Y. And then this here, right, how do I do that? Remember, it's 1 over the determinant. So 1 over the determinant, which is 5, 1, 2, 1. So that's going to be 5 minus 2, right? 5 minus 2, which is 3. So this is 1/3. And then I'm going to go take the transpose of this, right? And doing the transpose is going to be 1, 5, and then -2 and -1. And then remember, do not forget this 11, 4 here. Okay, so I'm going to give you some advice right now. My advice to you is to wait to multiply that fraction through. Because remember, this is a 2 by 2. And this is a 2 by 1. Therefore, I can multiply the 2 by 2s. I'm going to get a 2 by 1 when I'm done. I'm going to get a 2 by 1, right? But I still do need to multiply that 1/3 by it. And so, okay, so we're going to right? We're going to multiply the top row by the right column. So that's going to be 1 times 11, right? So 1 times 11 plus -2 times 4. Okay, what is that? 11 minus 8. 3. I like that number because, right, I'm going to multiply that 1/3 by it. Good. Okay, then I'm going to go, what am I doing? I'm going to find the row 2, column 1. So that's this row, row 2, column 1, right? And I'm going to multiply, let's see here, -1 times 11 and plus 5 times 4, so 5 times 4. So that's going to be -11 plus 20. Also like that number, because that's 9, right? Because now I've got a scalar value, meaning here's x, here's y. And once I multiply 1/3 times each number, what's 1/3 of 3? 1. And what's, right, 1/3 times 3 is 1. And then what's 1/3 of 9? And well, that's 3. So ultimately, heads up, we did it. Our intersection point is 1, 3. Right on. Don't you love this? I love math. Okay, so this right here is another way of solving a system of equations, and we're using matrices and inverse matrices to solve, right? Oh, let's do it one more time just for fun. I mean, what else we have to do? So we're going to set this up. We've got this little box, right? Okay, so we're going to go 2, 1, 3, -2. And I'm going to solve that. I'm solving for x and y. And then my resultant is 5 and then 4. Okay? So ultimately, right, we're trying to find our intersection point. That's what we want. So I need to get x and y by itself. So we want that by itself. Isolate that. Move this to the other side. So in doing that, that's 2, 1, 3, -2. Yeah, inverse. And then we're going to multiply that by 5 and 4. Okay. So the inverse is what I'm working on. And this just gets kind of like rewritten. The inverse is going to be 1 over the determinant, right? The determinant is 2, 1, 3, -2 times the transpose, right? The transpose of this is MT. The transpose, this is 1 over, this is my determinant. And this formula is on that other page. Anyway, the transpose flips these two numbers. So this -2 goes up here. This 2 here goes down here. And then 1 becomes -1, 3 becomes -3. Oh, and don't forget this little number out here, right? Our resultant. So we got to multiply some stuff with that. Okay, so we have xy, and then we have 1 over our determinant. So let's just do that somewhere. So our determinant is going to be -4, right, -3. So -4 minus 3, -7. Yeah, so that's -1/7. And then this becomes -2, -1, -3, 2. Actually, I didn't change that, right? And then this is 5, 4. Okay, so what we're going to do now is don't do the -1/7. Do not multiply that in there. I know you want to. I hope not. But don't do that. Because this is a 2 by 2, and this is a 2 by 1. 2's cancel, right? Because those are the same. That tells me that I can actually multiply those two together. And now I'm going to go 2 times 1. Or that's a 2 by 1. So realistically, my solution is going to be xy equals -1 over 7. And then there's my 2 by 1, right? That's my 2 by 1. Okay. Remember row times column. So to find row 1, column 1, that's the space right here, right? That space, which is row 1, column 1. I need to multiply row 1 by column 1. Okay, so that's going to be -2 times 5 plus -1 times 4. What is that? -10 minus 4 is -14. Love that, because look at that 7, loving that. And then now I got to find the next spot, which is row 2, column 1. So I'm going to go this row times this column. So that's going to be -3 times 5 plus 2 times 4. I know you guys are seeing me do this kind of thing. Just as in my head, I have to do that. So that's -15, add 8, which is -7. Also love that, right? Okay, so that means that my final answer, xy, is going to equal, and I've got to take this -1/7 and distribute it. So -1/7 times -14 is 2. And so that's 2. And then -1/7 times -7 is 1. So that means that 2, 1, oh my goodness, and I almost forgot. I can't believe that. But 2, 1, I think I forgot on the other equation to check my answer. Oh my goodness. Oh, okay. 2, plug it in. 2 times 2 plus, hello? It's not working. 2 times 2, add 1. That's 4 plus 1, which is 5. Check. All right, so we found our intersection point. Happy are us. And then we are done with that. right? I think I put in another equation so that if in case you wanted to have some more fun and doing another problem, maybe. Let's see. Go to the next slide. Yes, I did. So I think 1 or 2 problems. So you guys can use 2, you can play around with this and do some more problems. But what I want to really show you is how to use this, how to do this on a calculator. So what I'd like you to do is take out your TI Inspire or your TI-84. So I use both. I like the Inspires better. You're going to see why. But also the TI-84, I am going to show you how to do that on the calculator in class. So right now I'm going to open up my calculator that I have. And the first thing I actually want to do is I want to show you how to find how to solve, but also just to find a determinant, like a value. So let's do that. Let me get my calculator up and at 'em. I'm using the Inspire here, the TI-84. I'll try to get that by class time. I'll do what I can. Okay, so what you're going to see is, the first thing you're going to see here is you are going to have to pick, what you're going to do. We're going to use a calculator. So we're going to click on Add Calculator, and so now we have that, okay? All right, so I think I need to make this a little bit smaller so it matches up with my, there we go. Okay, so there's my calculator. Now, what I want to do first is I want you to find this little button down here in the right-hand side middle, and it looks like a little box like this, and you can see like all these fun things that you can do, all these, right? You see, oh, there it is. Fractions, oh, there it is, right? And the matrices too. So we're going to click on, let's just click on this 3 by 3 for fun. Now, this is a 3 by 3, all right? And what I'm going to click OK. And what I have is a matrix. Now, in my slides last week, what I asked you to do actually was I want you to write determinant. If this is the kind of calculator you have, I want you to write determinant. Because what this is going to do is it's going to do that Cramer's rule shortcut, or it's going to do the higher order thinking, right? And I want to plug in those values. So I'm going to just try to see, I'm going to try to use those values that I had in the other problem. And I think that was 2. So I'm going to plug these values in, right? So I've got 2, 3, -1. And it's a little bit tricky because actually, see this negative sign? Make sure that you're using a negative sign, like that negative sign down there, right? Okay. Oh, actually, that's for that negative. Yeah, I think actually, yeah. Okay, so we're going to do this one. It's going to be also -1. This one right here will be 5. This will be 3. 3, and then -1. I'm going to see if it makes a difference. We'll see on this. And then last one would be -6. Whoops. -6. All right, well, I'm not sure if it's going to make a difference. We'll see. Oh, and by the way, I think I forgot to use parentheses. So I do have to use parentheses. Okay. Press enter. Enter. What does that give me? Oh, -31, which I think was like the top of one of my equations back then. So you've got -31 is like one of those. It's either the numerator or it's the denominator. Okay, so that's how to do that. That's just like a determinant, one of the values. But like, why do I have to do one of those values? So like, I would want to just be able to solve this whole thing. So I'm going to do this. I'm going to clear. I'm going to clear this. How do I clear? Let's see. Oh, go calculate. New paper. All right. So I'm going to use this again, but I'm going to use my equation. So I'm going to use my 3 by 3 again. And this has to do, actually, okay, go back 1. I'm going to go calculate, and instead of using a 3 by 3, I'm going to try a 2 by 2. I want to do like one of those problems that we just did. So there's my 2 by 2. So click on that, And what was the number? So I didn't have to figure that out. I'm going to pause you guys for just 1 second to get that value. Okay, so the equation was 2x plus y. So plug those numbers in. So 2x plus y, y was 1. And then the other one was a 3x minus 2y. So I'm going to go with negative 2 for the negative 2y. And then remember, we did the inverse. So I'm going to hit the hat button, which is over here in the left corner, and I'm going to go negative 1. Now, it's important to use the arrow button to go over. So use the arrow button, because otherwise everything's going to be up on the exponent. And then the next thing is like the 2 by 1. So I got to go back to my little value here. I'm going to click on this. Oh, there it is right there, 2 by 1. So I'm going to click on that, and I'm going to type in the number 5, and then I think it's 4. Okay, so this should be the same equation like we just did. Make sure you're over to the right. I'm just going to hit enter and see I get 2, 1. Yay, that was super fast, right? So that is how you find the intersection point for a 2 by 2. And then I want to do the one problem that we did like multiple times. I'm going to do this again. Calculate. I'm going to delete this. No, I'm not. Okay. And then we're going to go matrix. And this is going to be a 3 by 3. So I'm going to click on that. 3 by 3. Okay. And remember, our favorite problem of today is 2, 3. And then this was negative 1. And then we had negative 1, 5, 3, and then we had 3, negative 1, negative 6. Yeah. And so now it's the same concept. So now you're going to use that hat button, this thing looks like a house, right? Negative 1, because we're finding the end. This is how you do like a 3 by 3 on the calculator. We didn't actually do this by hand. Now, see how my cursor is way up there? You got to make sure that it's back down where it's supposed to. So use your arrow key to go to the right, and then there you go. And now I've got to do that answer column, which is a 3 by 1. And I don't think there's a 3 by 1 on here. That is not the same thing right there. So what I have to do is actually plug this value in. See, that's 3. And it's a 3, but by 1. So I'm going to go down to the bottom here, and I'm going to bring that, I'm going to make that a 1. Is that a 1? Nope. I want to bring that back up. That's a 3. Now I'm a 1. Okay, so there's a 3 by 1. And then you just have to plug that value in, right? Oops. Oh, where did that go? I just lost my calculator. Hold on a sec to bring it back. Okay, so plug those values in, and those values right on the top left was negative 1, right here, negative 10, and then 5. That was our favorite equation of the day. Hit enter. 3, negative 2, 1. Blah. Don't you love it when everything works out? Okay. So this right here is how to use your calculator. The TI-84, I'm going to show you in class, but basically second matrix, so you got to turn it on. And then you're going to go second matrix. And what's going to happen, I don't know if you can see this, but what's going to happen is you're going to see like a 3 by 3 and 3, and you have to actually type those values in. So you're going to go over to edit and then type enter. And then that's going to, you type in 3 by 3, and then you actually start typing in the numbers into the little grid. And then you have to quit out of that, and then you type matrix again and do a 3 by 1. And lastly, it goes matrix. So if you're using the calculator, you're going to go matrix A, inverse, use the hat button, and then matrix B, and then enter. And that will give you the same thing, but on the TI-84 instead of the TI-Inspire. And so here's, these are the problems that we did. We're done. Your homework is 5 problems. You have to do elimination, a CRAMER'S rule, shortcut, a higher order determinant, and a calculator. Also, I want you to do a 2 by 2 matrix inverse. So lots to do and I think you're going to have a great time doing it. Thanks for watching. You are smart to watch this, and I'll see you in class.